Okay, so just recapping what we did yesterday, we acknowledged that if I'm converting from degrees to radians, I take the degrees that I have and I multiply it by pi over 180, and then that will give me the radian equivalent to that degree. If I'm going from radians to degrees, I take my radians and I multiply by 180 over pi, and that will give me my degree equivalent. We wrote that down yesterday, correct? So what we're going to do right now is we're actually going to practice this using degree and radian measures. When we convert, I like us to keep it in a fractional simplified form. So I don't want decimals if we can avoid it. Okay? So let's go ahead and do a degree to radian conversion first. So for example, let's say that I'm starting out with 150 degrees and I would like to change 150 degrees into its radian equivalent. So I'm going to multiply by what? Pi over 180. A really good way to remember this is that whatever unit I have on top is the unit that needs to be in the bottom of whatever I multiply by. So I'm multiplying by pi radians over 180 degrees. I do this because in the degree in the top cancels out the degree in the bottom, and all I'm left with are radians. When I multiply it, I get 150 pi over 180, and then I just need to reduce this. So what's the largest number that I can take out of 150 and 180? 30. So when we take 30 out, we're left with 5 pi over 6. So 150 degrees is equivalent to 5 pi over 6 radians. If you want to put the R to remember that it's in radians, you can absolutely do that. What you thinking, Marissa?
No,
I multiplied 150 by pi to get 150 pi, and then it was over 180, sorry, because that was my denominator. And then I just divided 30 out of each of these.
why is there a pi on 180? And then where did they go from 6?
Oh, there shouldn't be one, I'm sorry. That was my fault. That was my bad.
Is there like decimals?
A decimal's a no-go. If you give me a decimal, I'm going to count it wrong.
I only did 5. So. Might as well just not a bad.
Okay. Is everyone okay with how we converted from degrees to radians? Would you like to do another one just as a practice? Yes, good.
Mm-hmm.
So let's go ahead and do, oh, I don't know. I'm going to make one up, make it a really good one. (1,265 degrees, I would like to convert into radians. So what am I going to do with that 1,265 degrees? Multiply it by pi over 180. This ensures that my degree unit is going to cancel, leaving just the pi, which indicates radians. Good. Now what do I do? Go straight across. Do I leave it like this? No, what am I going to look for? Largest common factor. Chances are I'm not going to find it right away, so I can start by just taking out the obvious common factor and then go from there. So what clearly comes out of both of those? 5. So what's 1,265 divided by 5?
253.
Somebody checking.
Yep.
I got it. So what's 180 divided by 5?
36.
Does anything else come out of 253 and 36?
I got it. Maybe
3 will not.
But now act like I didn't say that.
I I can't think of anything off the top of my head. Doesn't mean it doesn't exist, so you could test a couple. But if nothing else comes out, this is my radian equivalent. It doesn't have to be pretty. We're just looking for the simplified fraction. Everyone okay with that? Anybody have any major issues with that? So let's go the other direction. Let's say that I was given a radian measure and wanted to convert it into degrees. Here's my conversion. I take my radians and I multiply by 180 over pi, ensuring that my radian unit would cancel out and I'm just left with whatever my degree is. Let's do an actual example of this. Let's say that I have 7 pi over 4 radians, and I wanted to convert that into degrees. First thing I'm going to do is I'm going to multiply by what? 180 over pi. As I'm looking at this, what do I notice? The pi's cancel. And then I just have to do the 7 times 180 over 4 and reduce as far as possible. If you wanted to go ahead and multiply it out, we would have 1,260 over 4. And then I would look for something large that comes out of 1,260 and 4. 4, what is it? 15, thank you. So the equivalent of 7 pi over 4 is 315 degrees. How do we feel about that? Good? No major questions, concerns, or issues. Should we do another one just as a practice?
Yes.
Yes, good. I would like to convert negative pi over 11 into its degree equivalent. Yes, Colin. Yes. Well, we should always, as long as there's a pi in the radian I've been given. They're not always given to us in terms of pi, but in theory, yes. So Colin, since you already raised your hand, what am I going to multiply this by in order to turn it into its degree equivalent? 180 over pi. What did we already notice? The pi's are going to cancel, leaving me with negative 180 degrees over 11. Can I reduce that at all? No. So just out of curiosity, what is the decimal equivalent for this degree? Let's use our calculator and take it to 4 decimal places. 3636. Okay.
But I thought we wanted absolute values.
We do. I said out of curiosity, what is the decimal equivalent? Okay, so it is 100% possible to do this conversion of positive angle measures and negative angle measures. It still works the exact same, except a negative would have a negative answer and a positive would have a positive answer. Questions, concerns, or issues with that? Everybody okay with that? Do we want to do another example of any of those? This will be something that you will eventually have memorized, this conversion. Okay? Keep that in your brain. Until then, of course, I will give you a cheat sheet on the first assessment, and you will get to hopefully write that down because you're going to want it. So if you need to remember that you're going to have to write that down, star it, circle it, put it in a box, whatever you need to remember that this is an important conversion that you will have to have stored somewhere in your brain. I do not allow the 57.3 conversion. Okay? We are all about exact values, not rounded approximations. Although I will say if it came down to you not getting the answer right and you remembering that 57.3 is in there somewhere, you would get at least partial credit. So now that we've done the conversions for that, there is in the notes a nice fun little table that has all of the major angles between 0 and 360. It gives you their degree angle measure and the equivalent radian angle measure. This eventually will be memorized in your brain as well. Okay, for right now, I've written it out all nice and pretty for you. I would definitely take a look at that at some point. It is in your notes. I'm not going to write it out for you because that's a little excessive. Okay, so just know that that information is accessible to you. So, now that we have done these super duper awesome degree to radian and radian to degree conversions, let's do the degrees, minutes, seconds conversions as well. So we kind of hit on degrees, minutes, seconds yesterday. Today we're actually going to convert to that. I like to abbreviate degrees, minutes, seconds as DMS because I get tired of writing it all the time. But know that that indicates that I will have 3 portions to this angle answer. When we are doing a conversion into degrees, minutes, seconds, it is entirely okay if we have a decimal angle measure in there first. Okay, that's 100% fine. So we're actually going to kind of do a 2-stepper here. We're going to go from radians to degrees and then the degrees to the degrees, minutes, seconds. You can never go directly from radians to degrees, minutes, seconds. It doesn't work that way. You have to hit degrees in there somewhere. So first we're going to do the radian to degree. And we are going to convert 3 radians into its equivalent degree angle. So I put the R on there just to remind us that we're working with radians right now. And I know it's radians because there is no degree symbol on this angle. So what am I going to multiply 3 by to find its degree equivalent? Say it confidently. 180 over pi. So I'm going to take 3 and I'm going to multiply by 180 over pi. If you notice here, I'm not going to have a pi that cancels, which is why it's okay to get a decimal. So in my calculator, I'm literally going to do 3 times 180, which will be 540, divided by pi. And I expect my decimal to 4 decimal places if possible. So in your calculators, tell me what 540 divided by pi is. Okay, so 540 degrees divided by pi is approximately 171.8873 degrees, which means 3 radians is equivalently 171.8873 degrees. Are we all okay with how we did that? Your radian will not always be presented to you with a pi in it. That is okay. If it is a whole number with or even a decimal with no degree symbol on it, we automatically assume it's in radians. Everyone okay with that? So we did the radians to degrees. Now we're going to do the degrees to the degrees, minutes, seconds. The really cool thing is I already know the degree portion of my degrees, minutes, seconds. It's whatever the whole number is in front of my decimal point. So 171 is going to be the degree portion of my degrees, minutes, seconds. I can move this up, I'm sorry. To find the minutes portion, I'm going to take the entire decimal present and I'm going to multiply it by 60. Everybody in your calculators, take 0.8873 times 60 and tell me what you get. Say it again. which means 53 is going to be my number of minutes. Can you guess how we're going to find our number of seconds? We're going to take the 0.238 and multiply by 60 again. And that's going to give me my number of seconds. I only care about the whole number answer I get here. I don't care about anything after the decimal point. So what is 0.238 times 60?
14.28.
Which means the 14 is my number of seconds. So the conversion of 171.8873 degrees is equivalent to 171 degrees, 53 minutes, and 14 seconds.
Just not use the
No, after we do that second multiplication by 60, I only care about the numbers in front of my decimal point. How do we feel about that?
do another one.
Oh, we will. We definitely will. And then we're going to go the opposite direction. Yes, ma'am.
So the first one's like pretty much 0 and 1 and 2. Like, have different letters.
Oh, yeah, sorry. This is 1 apostrophe. This is 2 apostrophes. Yeah, so this one is minutes. A single apostrophe is minutes. A double is seconds. Kind of like inches and feet. Inches, we use the double apostrophe. Feet, we use the single. Major questions, concerns, or issues with that, though, before we do another example? I'll give you a second, sorry. I love this conversion. This conversion is probably my favorite. And going the other direction. I love that one too.
That one is easier.
Going the other way?
Yeah.
Actually, I think it's easier. We all good? Okay, so let's do some, I don't know, like super duper random one.
40 billion radians.
No. Just for the ease of practicing, we're not going to go from radians to degrees, minutes, seconds. We're just going to start with a degree and transfer to degrees, minutes, seconds. Because I think you guys can already do the radian to degree conversion, especially if we can turn it to a decimal. That's not a major issue. So let's go. I think of a really good one. Oh, I got a good one. Let's say that my degree measure is negative 57.9974 degrees. This is one that I absolutely love to throw on to a quiz or a test because a lot of kids will get caught up in like doing everything exactly the same and they don't think about what the number actually is. Okay, so before when we did this, we kind of assumed that we were adding these portions together. If we were adding together for a positive angle, what do you think we're going to do for a negative angle? Okay, so this goes for the other direction as well. If I were given a negative degrees, minutes, seconds, I would have to make sure I'm subtracting all the numbers together. We have to keep the same operation happening that matches the sign of my angle. Okay, so negative goes with subtraction, addition, or positive goes with addition. Make sure that's somewhere in your brain because that's a really easy thing to mess up for kids. Okay, so what's the first thing I can easily identify when I'm changing from degrees to degrees, minutes, seconds? The degrees, what's my degrees here, Colin? Negative 57 degrees. How do I find my minutes then? No, because it's negative on the front, we assume that covers the entire thing. Just make sure you keep that same thought throughout. So we take the 0.9974 and we do what? Multiply by 60, because there are 60 minutes in a degree. So I go ahead and I do that multiplication. What do I come up with? 59.844. Which means the whole number 59 is my number of minutes. How do I find my number of seconds? .844 times 60. Do I care about the entire number I get when I do the seconds multiplication? I only care about what? Whatever happens before the decimal, so the whole number a part of it. So what is 0.844 times 60? Give me the whole number just to practice. 15 or 50?
50.
Point what?
64.
And I only care about the 50 part of it, so that is 50 seconds. Which means that negative 57.9974 degrees is equivalent to negative 57 degrees, 59 minutes, and 50 seconds. Oh, never, ever, ever.
So this is just.
This is for this class,
To make us cry.
probably. I'd say that was love.
Well,
yes.
just make me cry or something.
Okay, questions, concerns, or issues with that? So let's go the other direction. Let's take a degrees, minutes, seconds angle measure and turn it into a decimal degree angle measure. Okay? So much fun.
Yeah.
Yeah. Fake enthusiasm. I love it. So let's take, I don't know. 19 degrees, 47 minutes, and 23 seconds. And I would like to find its decimal degree equivalent. If we multiplied by 60
5 by 60.
to go from degrees to degrees, minutes, seconds, if we're going the other direction, Gabe, what are we going to do?
5 by 60.
Divide by that portion's, that proportionality for the degrees, yes. So what this becomes, oh my gosh, stumbling over words. My 19 degrees stays the same. We already knew this because it was the same on the other direction as well. Since this is a positive angle, I'm going to add to it my number of minutes divided by 60 because there are 60 minutes in a degree. And then I'm going to add to that my number of seconds divided by what?
3,600.
3,600 because there are 3,600 seconds in a degree. So if you can't remember that, 60 seconds in a minute, 60 minutes in a degree, 60 times 60 is 3,600. And then you just put that into your calculator and you add it all together. And you should get approximately 19.7897 degrees. Of course, do this on your calculator. Make sure you come out to that answer. Did we all come out to that? Yes. Would you like to do another example?
Yes.
Yes. Okay. Any questions, concerns, or issues with that specific example? No? Okay. So let's go ahead and do another one. Again, going from degrees, minutes, seconds to degrees. Actually, we're going to go from degrees, minutes, seconds to radians. We're going to go the whole shebang.
I gotta go wait.
Let's do, oh, I don't know. No, just kidding. So let's do negative 47 degrees, 45 minutes, and 3 seconds. Yes.
So when we're like solving for it, what is the negative score? Right? You subtract. You have 47 minus, and then whatever you do to solve. So where do those negatives? I don't know. I think I don't know.
Are you talking about this specific example?
No, like earlier.
Earlier, we used as more of just assuring that we remembered we were dealing with a negative angle. On this one, we're actually doing the subtraction. So on this one, I'll show you. Okay, we'll just do it. Colin, talk me through the process.
So first, like negative 47. Subtract.
We would subtract because it's a negative angle. Yep. And you would put all of that in your calculator. And the reason we do subtraction specifically on this one is that if you were to do negative 47 plus 45 over 60 plus 3 over 3,600, that means you're taking that negative 47 and you're backtracking toward the positive side, which is not allowed because this is not negative 47. This is negative 47 and 45 minutes and 3 seconds, which means it's at negative 47 and then slightly to the left because I continued in that negative direction. So let's make sure whatever sign is on the front is the sign that we hold true through the problem with.
So when we write, but you agree, we don't have the negatives.
No, those are more just representative of the fact that it is a negative degree. But when you're doing the computation, they need to be present. So what did we come up with for this one? Somebody tell me who has the answer.
Negative 47.7508.
Show of hands, who else got that? Or close to that? Are some of you still doing it? Are some of you not doing it and just relying on your classmates to do the calculations for you? Let's make sure we're all practicing this because it's really easy to mess up when you're putting parentheses in, okay? So now that I have my degree, I need to change that degree into a radian. Because my degree is already a decimal, I can assume that my radian will also be represented as a decimal, okay? How would I take negative 47.7508 degrees and turn it into a radian measure? Multiply by pi over 180. Because I'm multiplying by something that has a degree in the denominator, my degree symbol is going to cancel, and I'm just going to be left with my radian unit. So somebody do that multiplication. Multiply this by pi, and then divide the whole answer by 180.
You don't want it in pi, do you?
No, I want pi multiplied into it. It's fine. Since we're going decimal, we might as well go full decimal.
Negative 0.8334.
Anybody else get that? Yeah, we're okay with that? Anybody confused by what we did or how we did it? Is everyone okay on all of my angular conversions? So degrees to radians, radians to degrees minutes, seconds, radians to degrees, minutes, seconds, degrees, minutes, seconds, degree, 2 degrees, and then to radians. That's most of it. I will say that we're like over halfway at this point. Well over halfway.
We're not close enough to finish.
No, we are not close enough, and we are definitely not going to finish today. So I might actually stop here and save arc length, sector area, and then linear and angular speed for tomorrow. Yes, there's overlap between trigonometry and
We
physics.
literally learned the same thing yesterday.
That's awesome.
So the
That's cool.
not
The homework will be due on Monday because I have to split this up into three lessons. I mean, I could make a video and make you watch it tonight and still have the homework due tomorrow, but I wouldn't do that to you.
don't do
Mackenzie, hun, did you hear that? The homework will be due Monday because we're gonna do another lesson on this tomorrow. Or continue this lesson tomorrow.